Hello everyone, my name is Renata. I'm the moderator of today's webinar on SysML model integration with MATLAB and Simulink. Welcome to the 6th session of No Magic MBSE webinar series. This session will introduce you to the main SysML parametric modeling concepts and use cases of parametric model analysis. The presenter will discuss using Cameo Simulation Toolkit as a parametric evaluation tool, and we'll also show you how to set, integrate, and use MATLAB Simulink to work with parametric models. The session will be hosted by Nerijus Jankevicius, MBSE Product Manager at No Magic. For more than 10 years, Nerijus has been contributing to UML and SysML standards working groups at Object Management Group, becoming one of the leading UML and SysML experts and consultants. Nerijus delivered workshops and trainings in systems modeling and model-based systems engineering at major facilities in research and industry, and gave numerous presentations and talks at international conferences. Today's presentation will take about 50 minutes and the question-answer session about 10. You don't have to wait until the end to ask the questions. If you have any, simply type them in the chat window, and Nerijus will answer some here after the presentation. Due to the limited time, other questions will be answered later and published with the link to our video of the recorded webinar. So, Nerijus, are you ready to start?
Yes. Thank you. Hello, everyone. So let's start. I hope you see my screen. That's outline for today's presentation. So I'll quickly overview the main basic concepts of SysML parametric modeling. Then switch to the tool demo, and I have a couple of examples to show to you, and we'll try to integrate and use MATLAB and Simulink models. And then at the end, we will please feel free to post any questions into the chat window, and we will read all those questions at the end. Okay, so let's move to the overview. So I'll quickly talk about parametrics and the tool itself, and switch to the demo. So let's start from basic concepts. So the main fundamental building block to do a parametric analysis in SysML is a constraint block concept. I have following slides on constraints blocks. Then usage of constraints blocks in parametric diagrams, and we'll explain how to bind your physical system properties to constraints, and how to pick different languages and so on and so forth. So, okay. So constraint block is the main concept, which is actually is a special kind of block. That means it is made as a block to be reusable. So that's the main purpose, to create reusable constraints. And here in this slide you can see a picture of a typical constraint block. It has a name and a constraints compartment and parameters compartment. In the constraint compartment you can see the equation or any expression in any language you wish, and then parameters used or variable names used in that constraint. That's a definition, and this block can be packaged into libraries, packages, and reused in different contexts or even different projects. Typically, you define those constraints in a BDD diagram, block definition diagram. Here's an example of several blocks. Then the next step is to use those constraint blocks, and that's the SysML has a special diagram type for that. It's called the parametric diagram, in which you can drop and use those constraint blocks and use special connections to constrain your any properties of your system or subsystem, any deep level properties together. So basically you're building a network or network of constraints and constraining those properties. Here is a typical example from our coffee machine model. So this is a SysML parametric diagram, and you see now in this diagram, if you drop constraint block, which was a block in BDD diagram, when you drop it into a particular context, like this diagram is actually the parametric diagram context is some block or analysis block. So in this context, a tool automatically creates a block usage, which is called a constraint property. So constraint property is the usage of the constraint block, and you can, after the semicolon, you can see a constraint block name. Then all those parameters then are represented in different graphical representation. They are shown as kind of ports, so you can see what inputs, outputs you want to connect to those equations, and then you can recognize those blocks from rounded corners. So you see constraint blocks have rounded corners, and then you see typical blocks, typical parts, and with some nested properties. And you can use binding connectors to connect your actual system properties to play some role in those constraint blocks. Then I will show you some step-by-step examples in the tool. Okay, and there are many practical applications of using parametric diagrams. So one of we had a special webinar on the topic, on the requirements verification topic. So you can actually refine text-based requirements in using constraint blocks, and then evaluate those blocks and verify requirements. Constraints are made to support performance reliability analysis. Then you can constrain and integrate analysis models, and also you can do trade studies, trade-off analysis, and use constraint blocks to define objective functions and do those measurements, effectiveness measurements, so you can compare different design alternatives. And another very useful application is using constraint blocks, recursive constraint blocks patterns to do a recursive mass power cost rollups. So then you need to calculate or have requirements on the total mass cost, which is a very typical in the aerospace domain when you have budgets of the power or mass and cost. In all systems we have cost restrictions. Okay, so we'll focus on a MATLAB, on one model example and MATLAB integration today, and all those topics. If you're interested, you could. I think we are planning to do more webinars on trade studies, trade-off analysis, and those rollups on those topics later. So you are welcome to check out our website or newsletters and register to upcoming webinars. Okay, for today demo topics, I'll show you how to define constraint blocks, how to use them, and how to change language, and what typical two modes of the parametric models are, and then how to provide inputs and record the results, and do a debug. And for all this, I'll use Magic Draw and as a modeling tool, and Cameo Simulation Toolkit as an evaluator, as a simulation environment and parametric evaluator. And we'll try to integrate MATLAB Simulink with those tools. So just a quick introduction to the tool. The Cameo Simulation Toolkit is a unique tool on market. It's very first commercial implementation of the standard-based executable UML SysML. And all execution semantics are standard-based, defined by different standards, different standard organizations. So the fundamental, everything is built on top of OMG FAML standard, which defines a foundational subset of UML, executable UML. And then on top, we have executable state machines, which is a standard from W3C organization. It's called state chart XML. Then we have an engine on top of FAML, and also support different scripting action languages, parametric solvers, and sequence diagram engine, and so on. So, and it's pretty unique because we solve those parametric models dynamically on top of running behaviors, for example. So behaviors can change values, and we automatically resolve parametric models. Okay. Our tool can integrate. So, okay. So first of all, we have built-in numerical solver, a math engine. So even out of the box, you can do a parametric modeling and solve those models. We have our math engine and mathematical function library. But typically, in your environment, if you have tools like MATLAB Simulink or Mathematica or Maple, you can integrate those tools. I will show you how. We have integrations, dialog, and then after integration, you can actually use the constraint blocks. You can drop those models from different tools into different constraint blocks, and actually even in the same diagram, you can use blocks or use MATLAB syntax or reuse MATLAB blocks, or also integrate Maple, JavaScript, and so on in the same model, in parametric or activity diagram. I'll show you how to do that. Then we have a command line, so we can communicate those tools. And the M files, MATLAB files, can be dropped into diagrams to create constraint blocks automatically. And you can also use custom MATLAB functions. You can invoke those functions from parametric diagrams. And if you have scripts, I'll show you how to modify scripts to create functions from scripts, or how to use those scripts directly. And then finally, Simulink model integration. I'll show you that. So let's switch to the demo. We have like 30 minutes for the demo. So first of all, I want to start from an empty project and show you some basic concepts of SysML parametric modeling. So let's create some block. Let's call that block, I don't know, system or any body. And let's say system has properties like speed, which is a real number, and let's say I want to use some equations like I want to calculate what's the distance given I have time and speed, and what is the distance. So that's I use a BDD diagram here to create blocks and constraint blocks. And you see, after creating a constraint block, you can enter the name. Let's call it distance, and then you can directly enter a formula here. So actually, you can even go to website or any document, copy math equations and paste here. So for example, the distance equal time multiplied by velocity, right, speed. That's my constraint block. Now you see I have a constraints compartment, but I have no parameters. So in most of the tools, you should do that manually. In our tool, we have a parser, automatic parser under tools, and we can automatically parse your equation and create those parameters for you. So that's my constraint block ready to be reused in different projects. So that's a basic, the dynamics, or you can create libraries for fundamental libraries for physics and so on. And now let's say I want to apply this constraint, this block to my system properties. So typically what you do, there are like 3 different ways or many ways how to use constraint blocks. So typically if you want to do analysis inside your system and you want to add those constraints into your system model, just simply create a parametric diagram. It automatically asks what properties you want to show in the diagram. So we have speed, and then drop constraint block. And if I connect, use binding connector here. Oops. Or let me show all parameters first. And then you see my property name is different from parameter name, but still I can use binding connector and bind my, speed is v, right? So I bind my speed to v, and for time and distance I have no properties yet. So I can even here directly in parametric diagram I can create missing properties. So I can create value property for distance, which is a real number or integer. Another valid property for time, and bind distance and time. We have a auto layout. We can don't worry, cross those lines, just bind parameters to properties and use auto layout to make a compact representation. So that's it. I have my system and I have one constraint. So now my properties are constrained and depends on each other. So for example, if I press, now I can press run button. So if you have Cameo Simulation Toolkit installed, you can see this run or evaluate button in almost every diagram because we support all modeling concepts. Just select something and click run, or if it's a diagram, just click run on the diagram itself. So in this case, I run a parametric diagram. It automatically opens my simulation window. You can see my window at the bottom. And in the variables panel on the right side, you see instantiation of my system in memory. So basically we create a runtime instance of the system so we can manipulate those values. So by default all values are 0, and so let's set some speed to 60 miles per hour, let's say, and time like 2 hours, and you see that my distance is automatically calculated. And when I do this solving, you see there is no solve button, just every value change automatically triggers a parametric model execution. So that's very, very useful if you have dozens of those models and you don't know who changes the value. So you can plug a user interface mockup, so user can interact with the model and change values. You can change values here directly, or some external source can change the values using our API, and so on and so forth. So, and every value change automatically triggers pending values update. So here in the middle you see the console and see the log, and we have different categories. So if you want to debug, switch to debug mode, and if you press refresh, you can force recalculation of all constraint blocks by clicking refresh. You can see that we do the math, and we use built-in map engine here. Okay. So that was a very, very simple example how we use this equation to actually solve to actually derive missing value. So we actually solve this equation and derive missing value. But there is another mode in which we can actually check equality, not solve but check. So for example, if I have a constraint or requirement on my speed and say that, you know, the maximum speed of my vehicle, let's say, is let's create new constraint property and let's say name it speed constraint and enter the constraint itself here directly in parametric diagram, and let's say speed should be less or equal 200. That's maximum speed, right? And then I can bind this my speed to this constraint, and now you see there is no output here. So here we have in a typical mode we have 3 parameters, and one is kind of result, right? Typically we set those causalities automatically. So one is a result of given values, and here we have no output. So actually we're trying to solve this to true or false. So we can do the checking. So if SP is less than 200, and this result is not even recorded. In this case, there is no output value for this. But if we solve this model, I rerun, and you see we automatically then show green or red color. We automatically check the constraint. So 200. If I use 150, it's okay, and I can read the tooltip. It says that speed should be less than 200. If I enter 220, it's not okay anymore. And I'll show you examples. And in big models, you may have multiple requirements and constraints, and you can see how actually doing some experiments you can just see accidentally see that, oh, when I did that, some requirement you don't even thought that it's related to somehow, now it's violated and failed. It's very useful. Okay, so 2 modes. You can solve some values, derive values, or you can do a like automatic requirements verification and see those colors. Okay, so that was a built-in math. So now let's move to okay, how to use other solver. So first of all, I want to show you that every constraint you have, so look at the left side, that's my model browser and that's my distance constraint block. If I click on my constraint, it has specification, and if I open it in a special window, you see that specification itself has language and body, and by default language is unspecified, or when we open this dialog it shows English. But if it's unspecified, we use our built-in math engine, our built-in solver. But you can click and pick any scripting language or any math external integrated tool as a language here. So for example, I can pick MATLAB here, and that's it. It will be solved by using MATLAB, because our solver will check the language and use appropriate, the solver for that. And now let's look what are the steps how to integrate MATLAB. So under tools, in our tool under tools, we have integrations dialog. Click on integrations, and then we show what tools are installed on your machine. So in my case, I have Maple and MATLAB installed, and then we show integration status. So my MATLAB is integrated. So integration is just one-click integration. Click integrate button, and okay, now it's integrated, so it has more options here. But just click integrate and specify the location of your MATLAB. So browse, for example, if you have 2 MATLABs installed, just browse and pick a directory, and that's it. And then depends on the system. As you know, Magic Draw is a cross-platform, so on Mac, I think that's it. It's integrated. No system restart is required. On Windows machine, typically it asks to restart Windows, but it's just one-click integration, and that's it. After restart, you should open this dialog again and see check the status, is integrated or not. If it's integrated, that's it. That means MATLAB integrated with the Sim toolkit, and it's very easy to check that. So if you even don't run any simulation, go to window, open simulation window, and in the middle we have this log, and actually we have a common window, and here you can pick any language and or tool. So if you pick MATLAB here, this common window is exactly the same thing as a common window in MATLAB. You can do exactly the same. We send this line to the MATLAB. We use a native integration. It works on all platforms, and you can do whatever you do in MATLAB. So, for example, check the version. Right, that's the easiest thing to check if it works or not. If you see the answer, that's it. MATLAB works. Integration works. And now I set MATLAB as my language in my distance constraint. If I run my same model again, my system, enter some values, and you see that actually all my constraints are solved using MATLAB. Not all. The one I changed the language, so distance is solved using MATLAB, and the speed constraint is solved using built-in math. So this is how you can actually use any number of those constraints and combine languages. Okay. Also, you see that actually you don't need to press a run button to do a parametric solving. So click run on diagram. It instantiates all objects and values, and parametric solver works on top of that. This run button in simulation window actually starts behaviors. If you have state machines, activities, it will start all the behaviors you have. For parametric model, it's not necessary. If you have parametric model only, like in this case, if you press run, it starts showing you the animation. It starts animation in your diagram, and you can always click, you can pause the execution and actually do a debugging. So for example, you can put breakpoints, right click on any graphical element in diagram and say add, set it as a breakpoint. So on my distance parameter, I put breakpoint in a, if I resume now the execution, so it's pretty slow, then I can adjust the speed. So if you want visual debugging, it's slow, but if you set full maximum speed, it's just instant solving. And here it automatically stops on breakpoint. So the red color means breakpoint, and you can point mouse and see all those values. So you see the result is 8. I see all values passed to my constraint block, so you can do the debug. Okay. So that was a small demo of main concepts, right? Constraint block, constraint property binding, and how to use tool to actually run evaluate parametric diagram. Now let me switch to my demo project, the bigger one. Actually, I use the same project I had in my requirements verification webinar before, but run different scenarios here. So I have vehicle model, I have breakdowns of the vehicle, I have wheel braking system, tires, and I have some parameters. But actually, I have no analysis models at all here. So in this model is pure. I just have a block structure and some parameters, some properties, and default values here. So what happens if I execute that vehicle? If I click run, you see I select vehicle block and click run. If nothing is selected, then it runs the entire diagram, but there's no point to run a BDD diagram, so you should select block and run this block here. It depends on the diagram. If it's a state machine or activity diagram, you can just click run on diagram. And in variables panel, you see my vehicle is instantiated. I see. Okay, I see all my vehicle properties here. And values, I can change values, but nothing happens because I have no constraints. My value change is not related to any other property. So then what I do, then I have I made a subtype of my vehicle, just a subtype of vehicle to do analysis. So I inherit everything from the vehicle, but put one constraint here to verify, to check what is the required stopping distance. So I used this same constraint or requirement in my previous webinar. So I have a table in my Excel spreadsheet. What is the required stopping distance on dry, wet surface, and it depends on the initial speed. So I actually used this equation here and use my vehicle speed as initial speed to calculate what is the required stopping distance for my vehicle according to the requirements in Excel. And then I compare actual stopping distance of the vehicle with the required one. If I click run, okay, let me switch to okay, warning mode. Now you see green color, and you can actually see that the required stopping distance is automatically calculated, and it depends on my speed. So now I can play with my speed. I can change my speed to 70, and I automatically see that for the 70 miles per hour, my required stopping distance is 204. But stopping distance remains empty because I have no analysis model. I don't have any design which could estimate my stopping distance. So I can do manual testing. I can run prototype and 60 miles per hour and measure what is this actual stopping distance, then enter this value here because it was 200, and it says okay, 200 is okay, it's fits into my requirements. But if it was 210, it's not okay anymore. For 60 miles should be 150. Okay, so I have requirements verification here. Then another subtype here is another analysis context here. I inherit everything I had before, but I put another constraint here. And here comes MATLAB. So I want to estimate my stopping distance, but I don't want to enter all those. I would expect many math here. And what if I have this model in MATLAB? So let me open MATLAB. You can see that I actually have a M file called a function called stop distance, and we have a bunch of equations here and many input parameters. So I see that the stopping distance of a car depends on many criteria, many properties. So it depends on initial speed, on the weight of the car, or the friction of the tires, and diameter of wheel or tire, and brake torque, and so on and so forth. Many parameters. So open this M file in MATLAB. Check if you actually have a function definition, which is it's not necessary but very useful, because if you have the same equations but without a function definition, we cannot identify what variables are used as inputs or outputs. But if you have function definition, just put if you don't have it initially, just put a function definition, name it, and list all those variables as parameters. Normally you have all those custom functions, and then just go to your file system and drop M file. You can actually preview, at least on Mac, preview if that's correct, M file, and drop it into parametric diagram. And we automatically parse MATLAB M file, identify a function and parameters, and represent it as a constraint block, constraint property, and parametric diagram. And we automatically show all those parameters. Now you just need to identify, find matching properties in your system and do the binding. So, for example, showing those properties is easy. Just click on parts. We have display internal parts dialog on diagram itself. If you right click, go to related elements, display parts, you can see entire context. And actually, you see the checkbox for the properties you already have in diagram. And for example, if you want some more properties from the wheel, that's a hierarchical. You see the full breakdown of the system. So inside the wheel, you have other properties of the wheel and so on. Then you have brake subsystem and so on. So for example, you need a diameter of the wheel itself, right? Click, and it's actually displayed inside the wheel box here. And then you can connect it to, let's say, a diameter here, which is actually incorrect because I use the tire diameter as an external diameter, which for the calculation of the velocity, angular velocity. Okay, so it's easy, just drag and drop function, and it automatically creates constraint block for you. If you can navigate, go to type, and you see that in your model it automatically creates constraint block, and then usage of that block as constraint property in this parametric diagram, and displays all parameters automatically. It's very useful and very easy. Okay, let me undo because I have this constraint already. You can undo everything in Magic Draw. Okay, and if I run this model, it actually calls MATLAB. Did I press? Yep, you can see my system instantiated in vehicles, in variables panel, and you see that the stopping distance is calculated now. So it estimates, it predicts what could be my stopping distance of my vehicle given this mass and the wheel diameter and so on, and the system of the brake system I have. So if I change any of those parameters, my stopping distance, estimated stopping distance changed. So for example, if I change my mass, I can immediately see that my stopping distance does not fit into my required stopping distance, which was 150. So now I run all those constraints in one execution, in one model. Okay, so you can play with all those values, do what if analysis. So it nicely fits. If I change to 70, it also fits. 200 almost as required. So margin is very low. If I change, even I can change wheels, number of wheels, because it's part of equation too. So then I have less surface, and actually my stopping distance is then the bigger. If I have 5 wheels, it's even better, right? But I have 4 wheels, and I'm happy with the estimated distance. But that's estimated distance. What if I have another model for my brake subsystem? And here I looked at the Simulink models, and I actually found one. You can if you have a MATLAB Simulink, you have this example model. They have a ABS braking system Simulink model. So I'll show you how to use this demo, example model and integrate that with my SysML model. So it has a Simulink diagram, block diagram for ABS system. So we can run and see, it opens plots and shows the vehicle stopping and the wheel, speed of the vehicle and the wheel, and you see that controller actually tries to unlock wheel. So that's, I'm browsing this description of this model on the web, and if you run Simulink MATLAB, you can open it. It's named SYL demo ABS brake. So it shows a Simulink block diagram. If you click, it goes deeper into wheel model. So it calculates the wheel speed here. And okay, let me, perhaps I have too many windows, same model open twice. So so the problem here is that I don't know how to connect that, what inputs and outputs it has. So let me show you how to do that. At least how I did that, how I checked what inputs can I pass. Because the problem is, if you look at this diagram, it has no inputs and outputs. That's the problem. Okay, if I open model, now it's okay. On the right side, you see in the workspace, it actually populates some some variables, and I can identify that v0 perhaps that's my initial speed. I could use and control is a control value, so it's 1 or 0, so it's a controller of the ABS system, and it has mass and friction and so on. So it has some parameters, but that's not all problems I have with this Simulink model. If I run it, it actually, what I'm interested in, I can see how speed changes, what is the time, stopping time, but I cannot see my stopping distance, which I need, because I have requirements on the stopping distance. And if you look at workspace, it has nothing, you cannot find the stopping distance. Even if you look at the model itself, it has stopping distance here as one of the outputs of the simulation. So actually it writes all those simulation values into the output file, into results file. And so I should find this file and take values I need. So I used a very small script for that, in which I can set some initial values like initial speed, how many wheels I have, or diameter and mass, and then actually read the file, which is, I found the file name in the help. So I read the file, and it has like a couple of thousands of entries and rows, but I read all stopping distance values in all simulation steps. And then I read the last one, because I want to get the final stopping distance. And I divide it by number of wheels. Okay, it's hard-coded here, 4 wheels. Because this model is the model of the ABS system of 1 wheel. So I have 4 wheels, so the stopping distance, let's say it's equally distributed, right? Okay, now if I run, so that's my M file. So I can run it. I run, and you can see now SD, my stopping distance value is populated. It's available in a workspace. So I can access it by an SD name. So I can do exactly the same in my MATLAB command line here. Oh, by the way, I forgot to mention that all those functions, M files, must be accessible by integration by MATLAB. So it's very easy to check. Just check the path, enter path command, and see all paths. So normally you can put your custom files into your user home or documents MATLAB, So then MATLAB can access those models. So now if I run ABS braking model from inside my braking, so it runs the same model, and I can access my SD stopping distance value here in MagickDraw now. So how would I plug that into my model? So I think this kind of braking is actually, it takes some time, and for me it looks like an activity, right? Braking is kind of behavior of my system. So what I want to show you how you can, instead of using parametric diagram and wrapping this M file into a constraint block, you can actually model a small behavior, like that's my state machine of the vehicle running and braking, and then actually braking is my activity diagram. And I simply wrap this ABS braking into an opaque action. That's UML, SysML element. It has, as a constraint, it has the same thing, the language and body. So I say that's my MATLAB and call this M file. That's it. And if I want to change some initial values, you remember the V0 and control. It has some more things like the diameter, mass, or number of wheels, but I only use those two in this demo. You can use the as a pins. You can access them, name pins, and you actually any value you pass into this pin in activity model. So in my case, I convert my miles per hour into feet per second and pass as a V0 into my MATLAB workspace. And then control value, that's my enable ABS, my property in my vehicle. I pass it into workspace too, and I can invoke the model with my initial values. Okay, press run. Okay, actually I should select block and run. So let me show you. I actually have vehicle ABS, another subtype of my analysis in which I have this activity diagram. So if I select my vehicle ABS block and run, it runs all constraints I previously used, but stopping distance is not. I'm not using an estimated stopping distance here because I want to use an ABS system to calculate that distance. Okay, let's say I have 60 miles per hour and the ABS is enabled here. And that's my activity model. I run my state machine by pressing run button. So I can show you that the state machine is running, my vehicle is in running state here. Then I can trigger brake, like pushing the brake pedal here. It goes into braking and it actually calls my activity model. Okay, I'll do this again. So, and you see it printed my Simulink result here, and it actually assigns the Simulink stopping distance value to my stopping distance property in my SysML model execution runtime model. And then we can compare this value with my requirements. I can trace that to my requirement. We can even have a go-to menu. I can go directly to requirement and check what requirement it actually satisfies. Now, if I change distance to 70, click brake again, and you see animation in activity, it assigns another value which fits into my required values. But okay, let me brake again, and look at this chart. You see the stopping, vehicle speed, and how actually how wheel was how vehicle was skidding when and if wheel was locked or not, and how controller works. But what if I disable that? So I can enter zero value. I can enter zero value here to disable my ABS controller and allow skidding, and then brake again. And you can see that it's totally different. it's like after 4 seconds or 3.5 seconds, actually my wheel is locked, and then vehicle is skidding, and it takes like extra. If you look at the value, it takes like extra 100 feet to stop, and more than 3 seconds more time for stopping. So you can see that if I use this braking system and if I use ABS, then I can satisfy all the requirements I have. So that means it's a modern car. I put this ABS system and I can satisfy requirements. If I turn this off, I cannot satisfy my requirements, stopping distance requirements anymore. So that was the demo, how you can use MATLAB as a solver, as a numerical solver, or how you can reuse MATLAB scripts and Simulink models, and how you can integrate and pass values and get results directly into SysML model execution environment. Okay, now it's time for questions, and we have many more topics we could actually discuss in future webinars, like doing a co-simulation on doing those model the clock and do step-by-step execution. And actually now I run entire model, like I don't know, like for several seconds simulation, right? But I could do this timing in my model, so we can discuss timed experiments in next sessions.
Thank you, Nerijus. Let's switch to the question answer session. Unfortunately, we have only a few minutes, so we'll try to cover the most general important questions. First of all, what MATLAB versions are supported?
Okay, so it depends on what Magic Draw or Sim Toolkit version you use, but we support all versions since 2010A, and so recommended version is 2012 A, but we also support the latest version, like 2.14 since Magic Draw version 18. So all recent versions, MATLAB versions, are supported.
Okay. How did you use Excel data and graph in your vehicle example?
Okay, vehicles. So in this case, okay, that was a different example. I could actually, I need to load another examples, but the spreadsheet data, I don't, instead of using spreadsheet data and importing those values into my model, I have an expression which produce the same data. So I don't know what analysis tool was used to actually convert a table into a function, but this function actually derives all those values for me. So, and I put this function into my constraint block, and I have all those values. But you can also import like initial data, like vehicle configuration data from Excel. If you use Magic Draw version, which is since version 18.1, I think, we have a copy paste. So you can simply copy data here and paste into Magic Draw generic table. So we have a generic table in which you can pick what element type is and what columns you want to show in the table. And if column number and type matches, we will fill data automatically. So you can copy paste and feed data. By the way, you can use MATLAB tools. In this line, MATLAB has nice tools to read Excel, to read any text, tab separated, comma separated data files. So you can actually execute those commands here and read files too.
Is Python, including NumPy, Spicy, supported too?
Okay, I cannot answer this. I need my help of my colleagues, but JavaScript, Groovy, Ruby, and Python are by default out of the box languages we support. And if yeah, I don't know. We can answer that later. Okay, let me mute a little. Reading more questions in the chat window. Just a second. So we have questions, timing related questions, which is a topic for another webinar or demos. What if I want to run simulation for some specified number of seconds? So actually time could be a variable too, and we can model clocks. And in our recent version we working on 18.3, we have built-in clock, so which allows us to generate those ticks and do co-simulation, integrate different Simulink models, and even FMI, FMU. We allow to drop FMU models into parametric diagrams and co-simulate, so we can simulate time. And also a question where this demonstration will be available. So we will post that onto YouTube channel. So you can Google for No Magic Webinars 2015, and you can find all webinars, descriptions, and links to YouTube. Or you can subscribe No Magic YouTube channel.
Thank you, Nerijus. I think we should.
Yeah. So keep posting questions into chat window. We'll look for interesting questions, and we can actually answer those in YouTube, I think, comments. And another question, of course, is this demo model public? Yes, we'll put it into standard examples under 18.3, and I think we'll also post it. So if you have using older versions, so we'll post it, some link into on our webpage or YouTube comments.
Thank you again for your participation. We hope to see you in the upcoming webinars. And if there's anything you'd like to ask or we didn't cover something today, please don't hesitate to contact us.
Yeah, you can send emails to us. We will be happy to answer.
Thank you and goodbye.
Okay. Bye.